Hello students, welcome to our channel. In this session, we are going to learn about quicksort algorithm. Previous class we discussed about binary search algorithm and we analyze the binary search algorithm. In this class, we learn about quicksort algorithm. Quicksort algorithm partitions the original array by rearranging it into two groups. Now, this is the array. Now, quicksort follows the divide and conquer strategy. Now, so this array will be divided into two parts, left array and right array. The first group contains those elements less than some arbitrary chosen value taken from the set, and the second group contains those elements greater than or equals to the chosen value. Now what it means? In quicksort, we are going to divide the array into two parts and you select one value. So for example, if I select the value 30, now we are going to place the 30 in the correct position in the array and all the less than elements to the 30 is stored in left side and all the greater than values stored in right side. Here in quicksort, the chosen value known as pivot element. Okay. Now you understand what is a quicksort. Quicksort we are going to use to sort the elements. Now the array is divided into two groups. One is left group, another one is right group. Now this left group and right group arranged based on one chosen value. So that value we called as pivot element. Now once the array has been rearranged in this way, the respective to the pivot, the very same partitioning is recursively applied to each of the two subsets. What it means? There is an array. Now array is divided into two parts, left and right array, and you are going to place the pivot value in correct position. Now all the less than values are stored in left side and all the greater than values are stored in right side. Now the same algorithm you are going to recursively apply to the array. Okay, that is a concept of quicksort. When all the subset have been partitioned and rearranged, then the original array is sorted. Now the array will be in the sorted format. So let us discuss quicksort algorithm theoretically, then we move to algorithm. So first choose one value. Here I choose 30 as a pivot value. Now what is a pivot value? So pivot value is 30. Now the 0th index is low. So this is the 0th index and the last index is high. Last index is high. Now what is a quicksort algorithm? We are going to place 30 in the correct position. Now what is the correct position to 30? Now let us assume, so this is the array. So this is the 30 position. Now after one iteration, all the less than values are stored in left side, all the greater than values are stored in right side. Now we see how. Now this is the 0th index is low, last index is high. Now you compare 30 with 30. Now it is true. So increment the low value. Increment the low value. Now low value become 1. Initially it is 0. Now it is 1. Now the low is incremented. This is the low. Next you compare pivot value 30 with 19. Again it is low. So increment low value. Now what is the low? 2. Next compare 299 with 30. So 299 is greater. So stop here. Then comes to high. What is high here? High equals to 7. Now all the left side are less than, all the right side values are greater. So here we are going to compare the numbers are greater than 30 or not. Now 46 is greater. So decrement the high value. Now high becomes 6. Now this is the high. Now you compare 39. So 9 is greater? No, 9 is not greater than 30. So stop here and interchange low with high, these two values. These two values. Now this is the resultant array 30, 19. Interchange means 9, 35, 28, 299, 46. Okay, this is the high. This is low. Again you compare 30 with 9. Yes, it is low. So increment low. Now this is the low value. Low becomes 3. Now you compare 30 with 35. It is greater. So stop. Then you compare 30 with high. 299 is high. So decrement high. So now this is the high. Now high becomes 5. Now you compare 30 with 28. So 28 small. So stop. Now interchange these two values. So resultant array is 30, 19, 9, 28, 35, 299, 46. This is low. This is high. Now again you compare 30 with 28. Yes, it is less than. So increment low. So now this is low. So what is low value? Low value is 4. And you compare 30 with 35. So 35 is greater. So stop here. Next compare high value 30 with 35. Yes, 35 is greater. So decrement the high value. Now high minus 1 means this is the high. Now 5 becomes 4. Now we repeat this loop until low less than high. But here 4 is the value of low and 4 is the value of high. So 4 less than 4 is false. We stop here. And final swapping here, you swap the high value with pivot value. What is the pivot value? 30. That means this is the pivot. What is high value? So this is the high value. This is pivot value. Now you change these two values. Now what we get? 28, 19, 9, 30, 35, 299, 46. Now you observe. So this is the pivot value. All left side values are smaller values than 30. All the right side values are greater than 30. That's it. What we discussed previously here. So these are the remaining 28, 19, 9, 30, 35, 299 and 46. Okay. That's it. Now, so this is the partition. Now again you apply recursively same algorithm on left side and right side. Now you consider this. So this part 28, 19, 9. You apply the algorithm. Select the 28 as a pivot and perform the operations. So finally we get the sorted array. So that what we discuss in first slide. So quicksort algorithm partition the original array by rearranging it into two groups. So these are the two groups 1, 2. The first group contains those elements less than some arbitrary chosen value taken from the set. Here the arbitrary value we chosen is 30. The second group contains those elements greater than or equals to the chosen value. So this is the first group and second group. So all the values are less than the 30. The second group values are greater than the 30. The chosen value known as pivot element. Once the array has been rearranged in this way with respect to the pivot, the very same partitioning is recursively applied to each of the two subset. The same algorithm we are going to apply to left side and right side. Then when all the subsets have been partitioned and rearranged, then the original array is sorted. Okay, so this is the basic idea of quicksort. I hope you all are understand quicksort. So this is the algorithm. Quicksort low, high. So what is the low? Low is the 0th index. High is the length of the array minus 1. Now here you are going to give sort the elements A of low. A is the array up to A of high, which resides in the global array A. So this is the array A, and we are going to do the partitioning until the low less than or equals to high. We are doing the partition. For that we are giving the input array, low value, high value. Okay. Now this is the partition. In this partition we are taking one V. So V is the pivot element and I value is low here, J value is high. So we increment the I value until A of I greater than V, and we decrement J value until the value is less than the pivot. Okay, I hope you all are understand based on our example. Here I explain clearly I and J. I is low, J is high here. We done some swapping operations, that is a interchange. Interchange, this is the code. Interchange means simple swapping. Here we are doing this until the condition I greater than or equals to J here. Okay. A of M equals to A of J and A of J equals to V. That means the partition elements belongs to at position P. That means at the finally we interchange the values of pivot and high value. That so that is a here. Okay, and finally we return the J. J means the high value index. In this case the high value index is 3. Okay, that is sent to here J. Okay, so now in next iteration we call the same quicksort. The same quicksort called here. Now quicksort low. What is low here? 0, comma, it returns J. J minus 1, 2. Okay, now we are applying the same algorithm on 0 to 2. Okay, so this is about the algorithm. Now, so this is the program for the same algorithm. So 3 functions, swap is for interchange, this is for partition, and this is for quicksort. Okay, here I am giving the values 30, 19, 299, 35, 28, 9, 46, and I call the quicksort. Elements is the array name, 0 is first index, that is 0, low, and length of elements minus 1 is high. Okay, so that means the first one is start, second one is end. Now we execute the program. I am debugging this program. You try to observe the values. Okay, I call the function. What is the elements? This is the array 0, and what is the length of elements minus 1? That is 7 minus 1, 6. Okay, that means the start is 0, end is 6. Okay, we check that 0 less than 6, true. So partition, elements, start is 0, end is 6. We call the partition function. So this is the partition function. I am taking first element as pivot, that is 30. While start less than end, what is the start? 0, less than end is 6, 0 less than 6, true. So enter into the block, we check that 0 less than length, that is 7, yes it is true. Now elements of start, what is the start? 0. Elements of 0 means 30. 30 less than 30, true. 30 less than or equals to 30, true. So increment the start value. Now start become 1. Now again same. Elements of 1. Now elements of 1 is 19. 19 less than or equals to 30, true. So again increment the start value. Now start becomes 2. Again elements of 2. What is element of 2? 299. 299 less than or equals to 30, false. Here we stop. Now we move to next loop. While elements end is 46. 46 greater than 30, yes it is true. So decrement the n by -1. Next element 9. 9 greater than 30, yes it is false. So we stop here. Now we check another condition, start less than end, 2 less than 5, true. So we swap start and end points. Now start is 2, end is 5, elements are, these are the elements. Now if we interchange, 299 stores at 5th index, 9 is stored at 2nd index. Okay, this is the swapping, just swapping. Again we are doing the same. Now you compare, what is the start value? 2. Elements of 2 is 9. 9 less than 30, true. So again increment the start. In next iteration, elements of start is 35. 35 less than 30, false. So we move to next loop. 299 is greater than 30, true. So decrement the n by -1. Next 28. 28 greater than 30, false. So again we move to here. What is the start value? Start value is 3. What is end value? 4. 3 less than 4, true. So swap start and 4. The elements are, the simple swap here. Okay. Now this is the swap, 30, 19, 9, 28, 35, 299, 46 in the list. Next what is start? 3. 3 less than 4, true. Enter into the block. What is start of 3? What is elements of 3? 28. 28 less than 30, true. Now start becomes 4. 4 less than 7, true. So what is elements of 4 here? 35. 35 less than 30, false. Now what is start? 4. What is next one is 35 greater than 30, true. You decrement the end value. Now end value becomes 3 now. Observe that the end value becomes 3. What is start? 4. 4 less than 3. So we don't swap. That means we are going to do final swap here, that is swap of pivot index is 0, end element is 3 and this is the list. Now you interchange. So this is the interchange. Resultant array is 28, 19, 9, 30, 35, 299 and 46. Okay. Now this returns end. What is the end here? The end is 3. Okay, return 3. That is assigned to Pi. Quick sort. Again. So this is the elements. Here we call the quick sort recursively. Pi minus 1 means 3 minus 1, 2. Okay. Now on this array we are going to apply the same quick sort, same algorithm. Now what is the start value? 0, end value is 2. Same function we call. Okay. So pivot value is 0. Element of pivot now 28. Now start is 0, end is 2, true. Start is 0, yes, it is 7, 0 less than 7, true. And elements of start is 28, 28 less than or equals to 28, true. So increment the start value. Now start becomes 1 now. What is the start of 1? 19. 19 less than or equals to 28, true. So increment the start. Now the start value becomes 2. What is elements of 2 now? 9. 9 less than 28, yes, it is true. So start equals to plus 1. Now what is elements of 3? 30. 30 less than or equals to 28, false. Now what is start value? The start value is 3. Now you compare 9 greater than pivot, that is the 28, false. Now what is start? 3. What is the end value? 2. 3 less than 2, false. So what is the start? 3, end is 2, false. We move to final swap. Pivot index with end. What is the pivot index? 0, end index 2, elements. These are the elements. Now you interchange 28 with 9. Now what is the resultant matrix? 9, 19, 28, 30, 35, 299, 46. Again you apply you return the value. What is the end value? 2. The same function. Quick sort 2 minus 1, 1, 0 comma 1. You observe that we reduce the problem size. 0 less than 1, true. Partition 0 comma 1, that means only 2 elements. So this is the pivot value. Now pivot value is 9. What is start? 0. What is end? 1. 0 less than 1, true. 0 less than 7 here, true. Elements of start 9. 9 less than or equals to 9, true. So increment the start. So start becomes 1 now. Now what is elements of 1? Elements of 1, 19. 19 less than or equals to 9? No, it is false. Okay. Next move to elements of end. End here is 1. 1 is 19. 19 greater than 9. So end becomes 0 now. Okay. Now 9 greater than 9, false. So what is start here? Start becomes 1, end becomes 0. 1 less than 0, false. So next 1 less than 0, false. Now swap pivot index. Pivot index is 0, end is 0. So this is the element. 9 swapped with the 9 only. We get the same array as a output. If we end is 0, that means we apply the quick sort, elements are same, the start is 0, 0 minus 1, we return minus 1, so it return none here, okay, false. Quick sort elements, so these are the elements. For this function call, it is 1 comma 1. So 1 less than 1, false. That means that we complete all the elements in left side. Okay. So next 3 less than 2, false. In all the cases it will be false. 4, what is the end? 6. That means the first function call. The pi value is 3, 3 plus 1, 4, 4 less than 6, true. So now we are doing the partition on right side. 4 to 6, that is 35, 299 and 46. Now what is the pivot value? The pivot value is 35. 4 less than 6, true. And what is the pivot value? 35. 35 less than or equals to 35, true. So increment the start. So start becomes 5 now. Now elements of 5 is 299. That is false. Why? Because 299 is not less than 35. So move to next one. 46 greater than 35, it is true. So decrement the end value minus 1. Now it becomes 5. Now 299 greater than 35, true. So again n becomes 4 now. Now 35 greater than 35, it is false. Now what is the start value? The start is 5. What is the end? End is 4. 5 less than 4 is false. Now we move to final swap. Now again you check 5 less than 4, true. So we move to final swap. What is the final swap? 4, end is 4, the same swapping. That means 35 is placed in the same 35 place. Okay. Now this is the resultant matrix. 9, 19, 28, 30, 35, 299 and 46. Now you return the value 4. Again you apply the start 4, 4 minus 1, 3. So this will be fail. Why? The low start is not less than n. So false. So it returns none. So now here we apply the same algorithm recursively. Okay. You observe that. So now the start is 299. Here what is the pivot value now? The pivot value is 299. 299 less than or equals to 299. So true. Start becomes 6 now. Now 299 we compare with last one, that is 46. Here false. So start less than, and it is false. The final swapping, the pivot index is 5, the end is 6, the element, these are the elements. So swap. Now this is the resultant matrix. So if you print, what is the element? 9, 19, 28, 30, 35, 46, 299. Now the array is in sorted order. So next class we are going to analyze quicksort. Thank you.